Hello everyone, my name is Shaban Hashim Mchomvu, and today we are going to learn a topic of complex numbers and a part of introduction. A complex number is an expression of the form that is a plus b I, where a and b, they're just real numbers, and this I, it is the radical of -1. So we can just say introduction. That's a definition now. A complex number. Expression of a form a plus b I. As we said earlier, that say this a here is a real part. Is a real part of a complex number. Maybe we can say z. That z represent a plus bi. So a is a real part of that complex number z, and the express as the real parts of the complex number z, that is a. But also, coming to the expression, here we have the term bi. The term bi, that we can say this b is an imaginary, it is an imaginary part of the complex number z, expressed as I m then of z. The term imaginary means something that does not exist. So we are learning for perfect knowledge. But a complex number now has only two parts. That's the real part and the imaginary part. But this I here, as we say, I, that is the one that forms a complex part. It is the root of -1. Or if we don't want to express in the square root form or the radical form, we can say when you're applying square both sides, it becomes I square equals to -1. So when writing now a complex number z that is a plus bi, we can say this a is the real part of complex number z, and this b here, it's an imaginary part of the complex number z. So it has got two parts. So now let's see how do we operate now the complex numbers as other numbers. For example, decimal numbers, we normally operate the whole number parts and the fractional parts. The whole number parts, we can just operate them, natural numbers, and so on. So how do we operate the complex numbers? So operations. So when we say operation with complex number, what do we mean? We mean the basic mental operational skills that addition. Here we are talking about addition, how complex number are added, also subtraction. How do we subtracting complex numbers? Then multiplication, And the last key that we are going to learn is the division of complex numbers. The division of a complex numbers. These are the basic mental operational skills that can be applicable on simplifying complex numbers. Addition, adding, and the subtracting, complex numbers. Now, for example, suppose complex numbers z equals to a plus bi, and a complex number w equals to c plus di. So for the case of addition, when we have z plus w, the value of z is a plus bi, so we add with w, which is c now plus di. So on adding complex number, as I said earlier, we are going to add the parts. That here the real parts of complex number z is added to the real parts of the complex number w. And the same applies to the imaginary parts of the complex number w, which is b, now is added to the imaginary part of the complex number w, which is d. So we do like this. So it is a now plus c. Now we plus the bi plus di. So on adding now these two complex numbers, it means the answer that we are going to get is also a complex number. So here it becomes a plus c, and then now we add, we factor out I, so we'll have b plus d. So still we are getting the complex number, and what has changed now to our sum here, the real part become a plus c, and the imaginary part become b plus c d. So this will be the addition of our complex numbers z and w. What if it's the case of subtraction? Now for the case of subtraction, we still do the same apply to addition. So real part is going to be subtracted to the real part, and the imaginary to imaginary. And still the complex number that we are going to get after subtraction, I mean the difference, it is going to become also a complex number. So z minus w, now here will be a plus bi, the value of z, minus brackets. So when subtracting, remember to introduce the brackets. So minus our complex number w, c plus di. So from here, it will be a plus bi. Now we open bracket with the this operator here. Here is minus 1. So when we open, it becomes minus c minus di. So now the real part is a, and here is c. So we operate them by subtracting, and now we plus bi minus di. So we get a minus c, then we plus, we factor out I, so as we can have the imaginary part now, b minus d. So also these complex number subtractions now resulted a difference, which is also a complex number. Now for the case of multiplication, we need to also, before learning multiplication, we need to learn a so-called complex conjugate. That is very, very important. So let's see the part of complex conjugate. We can say two complex numbers which differ only in the sign of imaginary are called the conjugate of each other. Yeah, suppose a complex number a plus bi and a minus bi. As you can see here, at the part of imaginary, here we have positive and here it is negative. So this a plus bi and a minus bi, the two of them now we can say are conjugate of each other. So suppose maybe a complex number z equals to 2 plus 3i, that its conjugate now is denoted as z bar, the conjugate of a complex number z, now equals to 2. To the parts of imaginary, you change the sign. From positive, now it becomes minus. So it becomes minus 3i. So z and the z prime, z bar, this now becomes the conjugate of z. So the conjugate of z, it is 2 minus 3i. But this 2 plus 3i is a conjugate of 2 minus 3i. So the only issue is to change the sign of the imaginary part of a complex number if you want to find the complex conjugate. Now, where exactly this can be applied? It can be applied to the concept of division. When you divide complex numbers, we can apply the complex conjugate identity. Now, let's see the multiplication. Multiplying complex numbers. So here we are not multiplying real part to real part or imaginary to imaginary. So we mix. Real part can be multiplied to imaginary and imaginary to the real part. Suppose you are given complex numbers, z equals to 2 plus I, and a complex number w, which is maybe here 3, we plus 2i. And now you're asked to multiply, then what do we get if we multiply z and w? So z times w equals 2. Now we put the values for the z, complex number z, that is 2i, 2 plus i. Now you times a complex number w, it is 3 plus 2i. So this becomes, this 2 here multiply all these parts, and this I the same apply, multiply all these parts. So it becomes 2, then 3 plus 2i. Then again here, the imaginary part, that is plus I, now you times the whole complex number w. So from there, now we open the brackets. 2 times 3, we get here, it is 60, we plus 2 again, times 2i. So here you multiply the quotient, 2 and 2, it is 4, then that I, we just put it there. Coming to this part, I times 3i, it is 3i. Then now I times 2i, it becomes 2i square. But remember earlier when we were defining a complex number, we said I equals to the root of -1, whereby if we simplify here, if we square both sides, I square now becomes equals to -1. So in multiplication of complex numbers, where the product becomes with I square, it means now it can be replaced by -1. So here becomes 6, now we plus 6, we plus 4i, we plus 3i, we plus, here becomes 2 times -1, because I square it is -1. So from there, now it becomes 60, we plus 4i and 3i, it is 7i. And here now we minus 2. So real part 60 minus 2, it becomes 4, we plus 7i. So when multiplying complex number, also we are going to get the product, which is also a complex number, which you can just observe here, 4 plus 7i. So let's see now how we divide complex numbers. So let's also see how we divide complex numbers. Suppose a complex number z equals to 2 plus 4i, and another complex number w equals to 1 plus 3i. And now we are asked to divide z divided by w. Now this complex number z, when divided by complex number w, is the same as say z over w. So when you reach at this stage here, what is z now? It is 2 plus 4i over w, which is less more to 1 plus 3i. So because complex number, remember I involve the square root of -1. It means it involves radicals. And here to the denominator expression, which is the complex number 1 plus 3i, we have I here. So it's the same as say, it is 2 plus 4, the root of -1, over 1 plus 3, the root of -1. So we remember from the definition that I equals to the root of -1. So when we introduce now the value of I here in terms of radical, it looks like this way. So if in the case of this nature now, we need to rationalize the denominator. So when you rationalize the denominator, it will be simple now to simplify. So now this becomes 2 plus 4i over 1 plus 3i. Now we times, rationalizing factor become the denominator complex number. That it is now 1 minus 3i. It means we take its conjugate. Then over the same conjugate of 1 plus 3i. So it becomes like this way. So from there, we just multiply. So it will be 2 plus 4i, you times 1 minus 3i over a complex number times its conjugate, 1 minus 3i. So from there, when we have a plus bi, so you times with the same a, but its conjugate, minus bi. So this is the difference of two squares. The same as saying a square, you minus bi bracket square. The difference of two squares. So for our case here, there is 1 plus 3i and its conjugate, multiplying to its conjugate. So it's the same as say 1 square, which is 1 now, minus 3 brackets, then square to the 3i. So when simplifying, it becomes 1 minus, the 3 here will be 9i square. So it becomes 1 minus 9. I square is -1 according to the definition of complex number. That is, I square equals to -1. So here becomes 1 plus c. It becomes 1 plus c, 9. So it becomes c, 10. So from here, we have 2, which is now the real part, is multiplied to this conjugate here. That is 1 minus 3i. And we plus this 4i, we multiply with the complex conjugate, then over This one now we have obtained it is 10. So it's a matter now of opening the bracket and operating the like parts. So 2 times 1 will gets 2 minus 6i. This one becomes 4i, and this one minus 12i squared over 10. So when operating the like parts, so it becomes 2 now, negative 6i plus 4i, this becomes minus 2i, and here minus 12, you times I squared, which is negative 1, now over 10. So here now becomes so here it becomes 2 minus 2i negative times negative is positive, 12 times 1 it is 12 over 10. So operating now the real part, 2 plus 12 we get 14, we minus 2i over 10. So this is LCM, so it can be separated, and it now becomes the complex z when divided by complex w, it becomes 14 over 10 minus 2 over 10i. On further simplification, this becomes by 2 is 7, by 2 it is 5. We minus 1 over 5i. So also dividing complex number, we are going to end up with also a complex number as quotient. So up to there, that's marked the end of our part. And keep watching for the next sessions.